In this lecture, you're learning to solve a quadratic equation using what we call completing the square. So first and foremost, let's try to understand what's completing the square. So take for example, consider x squared plus 8x. Okay, so what must be added to complete the square? What this question is really asking you is, right now there's two of you, x squared plus 8x. What must I add to the family so that the 3 becomes a trinomial, and when you factor it, it becomes a perfect square? Okay, and you could try trial and error, and you will notice that the number that works is 16, because x squared plus 8x plus 16 factors into x plus 4 and x plus 4, which is another way of saying x plus 4 all squared. Okay, so the big question is there a formula? So the big question is, any formula? So is there a way you can generalize? And the answer is yes. So in general, if you have x squared plus bx, okay, any number, bx, then the candidate that needs to be added is going to be b divided by 2. So you need to have that number and square it. So the number you really need to add is b squared over 4. So let's check for our example. The number is at 8. Okay, I'm looking at this number. Now if you take 8 divided by 2, that makes it 4. And 4, when you square it, gives you 16. So it does work. Okay, and when you do that, the number on the other side is going to match this letter first. So x is going to be x. And whatever the number is used right here prior to squaring, that's the number that you're going to put over this side. So the number prior to squaring was a 4, so that's why on this side it says x plus 4. So it seems to work. Okay, so let's try. If let's say this was x squared plus say 10x, what would be the number I need to add, and what square would this become? So you will notice the rule of the game is take the number, divide by 2. So when you take 10 and you divide by 2, it comes up to be 5. So 5, when you square it, makes it 25. Okay, except this number 5 is being used on the other side. So it's going to be x plus 5 all squared. So before you start thinking everything is a plus, what happens if this was an x squared minus 10x? Then you notice that looking at this number is a negative 10. Negative 10 divided by 2 gives you negative 5. Negative 5, when you square it, also gives you 25. Okay, so the number you're going to add is always going to be plus. But this number prior to squaring, that's the number that's going to be used on the other side. So it's going to be x minus 5 all squared. Okay, so the number that is added is always plus, a positive number. Whereas the number that you use on the other side, writing as a perfect square, it may or may not be a perfect, may or may not be positive. It could be negative. Okay, so it depends. The coefficient of x. Now, what happens if the number does not divide evenly? For example, if this was x squared plus, say, 5x, what would the number be on this side? Okay, so the way you have to think is you're supposed to take the 5 and divide by 2. And then you're supposed to square it. So for this example, it doesn't divide evenly, so it has a fraction. Okay, so 5 over 2, when you square it, becomes 25 over 4. And then you write this as a perfect square, and that's going to be x, and the number prior to squaring is 5 over 2, so that goes over the other side. Now before you start thinking that everything is going to be x, what happens if now I change the letter? It's going to be y squared, say, minus 3x. Okay, and then same story, you're supposed to look at this number, which is negative 3. If you take it over 2 and you square it, the number comes out to be positive. It's going to be 9 over 4. Okay, that's the number I need to add. And when I do that, it becomes a perfect square, except now I have to match the letter. I have to start with y. And the number prior to adding is squaring is negative 3 halves. And that's the one that's used on the other side. Okay, so why don't I write down one or two of them for you to try. What if this was m squared minus m? Okay, what must I add? And what will it become? And then let's try n squared. Let's try a weird one like this. 3/4 n. What must I add and what will it become? So why don't you think about it and then you look at the next page for the answer. Okay, let's try that. So in order to fully benefit from this exercise, can you pause the lecture at this point? Okay, before continuing. Because I need you to think about it, okay, and then go to the next page to see the solution to these answers. Okay, so I hope you tried the two problems. So the first problem was m squared minus m. Now you notice that without a number it really means 1. So you're looking at -1 and you're taking half of it and you're going to square it. So the number you need to add is 1 out of 4. And prior to squaring, the number was -1/2. So that's going to be used on the other side where you put m minus 1/2 all squared. And the other one that I asked you was n squared plus 3/4 n. So what are you supposed to add? So if you recall, the way to think about is what's 3/4 divided by 2 and then you square it. Now that's quite a mouthful here, so you have to think of what's 3/4 divided by 2, like that. And equivalently, it's asking you what's 3/4 times 1/2. So really, this whole question is asking you what's 3/8 squared. Okay, so think about that. 3/8 squared tells me the answer should be 9 over 64. And how I got 9 over 64 was 3 out of 8 squared. So 3 out of 8 is being used on the other side. The letter is n, and so it's plus 3 over 8 all squared. Okay, so if you got that, you are good to go. Okay, so let's write down the steps to solve a quadratic equation. So solving a quadratic equation by completing the square. So let's write down the procedure. There is 5 steps involved. Okay, so let me write down the steps and then we can apply it to the problem. So the first thing I want you to do is to write equation with variables in descending order on the left and constants on the right. So the reason I'm writing to one side is because I want to see you solve the problem next to each other. Okay, so I'm going to write the problem right now. Let's get you to solve. So take for example, can you solve Let's try 2m squared minus 2m minus 3 equals 0. Okay, let's try that. So the first step says you need to rewrite the equation in descending order on the left and constants on the right, which means that you have to leave 2m squared minus 2m alone and bring the 3 the other side. Okay, so that's what step 1 is saying. So solve by completing the square. Okay, so that's what step 1 is saying. Okay, now let's do step 2. Step 2 is make sure coefficient of squared term is 1. So that's referring to the number that's in front of the squared term. That's referring to this guy right here. It's telling you that that number has to be a 1. Okay, so that forces you to divide everybody by 2. Remember, it's not a choice, it's you have to do it. And why is it that you have to do it? If you look at all the little exercise that we did earlier, look at this number in front. It's always a 1. Okay? So the little trick about taking the coefficient divided by 2 and squaring it, that really only applies if the squared term is 1. So that's why we have to do it here. And that turns this into m squared minus m. But on that side, I have a 3 over 2. So remember, I'm not dividing because it's common, but because I have to. Okay, it's not an option. All right, third step, what I need to do is to determine the number needed to complete the square on the left side. Okay, and then add this number to both sides of the equation. So remember, this is an equation, so whatever you do to one side you have to do to the other side. So what I'm looking at is the 2 pieces that's on the left, and I'm asking myself, what is the new addition that I have to plus to this group? Okay, so right now I have a m squared minus m. What number do I have to add to this family to make you guys a perfect square? So this was the little exercise that I just got you to do. So remember, the trick is to look at the coefficient. That's this guy right here, and that's, I'm looking at -1 divided by 2, but I need to square it. So that tells me that the new addition to the family is 1 over 4. Okay, but I cannot just add to one side. I have to add to the other side. So let's read again. Step 3 is saying to determine the number needed to complete the square on the left. Okay, and then you need to add this number to both sides. So it was decided the number was 1/4. So I need to add 1/4 to both sides of the equation, which is what I did. Okay, so that's step 3. So in step 4, it's saying that to write the left side as a perfect square and simplify the values on the right. Okay, so what I need to do is, now that the new addition is put into the family, now the 3 of you become a perfect square. So m squared minus m plus 1/4 makes it m minus 1/2 all squared. Okay, so if you're lost, you can look upwards. This is the example that I'm using right now. Okay, so this is the example I'm using. You notice that 1/4 was added because the 3 of you now become the perfect square, which is m minus 1/2 all squared, and that's how I got this number. But on the right side, I have 3/2 and 1/4 to add. So this I have to times 2 top and bottom, which makes you a 6/4 plus 1/4. So that makes it 7 over 4. So let's continue on the next page. But to have the complete notes, let's write step 5 here. That's where you apply square root property. Okay, so let's continue this on. so what I have on the previous page is that m minus 1/2 all squared is equal to 7 over 4. So now that it's packaged nicely, we can do what we learned in 9.1, where we bring the square over as plus minus square root 7 over 4, which is really plus minus square root 7 over plus minus square root 4. So I have m minus 1/2 is plus minus square root 7 over 2. And if I bring the 1/2 over, is 1/2 plus minus root 7 over 2. Since the two of you have the same denominator, I can share one fraction bar, and the answer become 1 minus radical 7 all over 2, and that's my answer. Okay, let's try another example. Solve by completing the square. So it's a 5-step procedure that I need you to learn, and this is something that is very useful. It's very important for you to know, especially in your next math class. Okay, so let's try this problem. 4x squared minus 24x plus 27 equals 0. Let's try this. So remember, step number 1 is to rewrite the equation with variables on the left and constant on the right. So first thing is to bring the 27 over, like that. Okay, and then the next thing is the coefficient of the square term has to be 1. That's this guy right here. So that forces me to divide by 4. Not by choice, because I have to. So x squared minus 6x equals negative 27 over 4. Okay, the two fellows on the left needs a new addition, and that's where I have to consider what to add to the family. Okay, and whatever I decide, I have to add to both sides. And the rule of the game is you're supposed to look at this number right there, and you're supposed to take half of him and square it. So that's negative 3 square it, which makes it 9. So the new addition to the family is 9. So once 9 is added, the three of you become a trinomial, and when you factor it, it becomes a perfect square, and it's x minus 3, all squared in this case. On the right side, I now have to deal with fractions, so this is like 9 over 1, so this is negative 27 over 4, plus, if you times 4 top and bottom, makes it 36 over 4. And that works out to 9 over 4. Okay, so all that comes to x minus 3 all squared equals 9 over 4. So step number 5 is now to apply the square root property, which tells me that I can bring the square over as square root, but at the same time, don't forget plus minus. So x minus 3 is plus minus 3 over 2. So this goes to 3 plus minus 3 over 2, which tells me that there's two possibilities. 3 plus 3 over 2, which is 6 over 2 plus 3 over 2, which makes it 9 over 2, is one answer. 3 minus 3 over 2, which is 6 over 2 minus 3 over 2, is 3 over 2. So there's two answers to this question, 9 over 2 and 3 over 2. So you will notice that this problem was solved by completing the square because it was asked. Okay, but then you notice in the next page, I'm going to solve the same problem using factoring, and it's a lot faster. So let's try that. Recall last example. What if the question just said solve? Okay, and 4x squared minus 24x plus 27 equals 0. So let's try. This problem actually is factorable. Think about it. This is the sum is negative 24, and the product is 27 times 4. which comes out to be 108. And what two numbers will multiply to give me 108, and yet the sum is 24. So if you're not sure what's the choices, you can go to 27 and 4, which is obviously not the right choice, but we can break this as a 9 and a 3, and this is 2 and 2. And you can maybe pair 3 and 2, which gives you a 6, and 9 and 2 gives you an 18. There you have it. So 6 and 18 gives you 24 if you put a negative between them. Okay, so there you have it. So my two factors are going to be, so I'm going to use 2 and 2 to give me the 6 and 18. So it's 2x and 2x. And then to get a 6, I will need a negative 3. And to get an 18, so this will give me my negative 6, and this will give me my negative 18, so I need a negative 9. So 2x minus 9 equals 0 tells me 2x is 9, which tells me x is 9 over 2. And 2x minus 3 equals 0 tells me 2x is 3, which tells me x is 3 halves. So same thing, I'll get two answers, 9 over 2 and 3 halves, which is what I got using completing the square, except you always have the option to do factoring as well. Okay, so what are the methods that we have seen so far? Methods of solving a quadratic equation. Okay, so far what you have learned is factoring, and this was back in chapter 5. Okay, and the other method that you saw is by square root property, and this was covered in 9.1. And now you saw the third way of doing it by completing the square. And this was seen in 9.2. Now in my next lecture, I'm going to show you the last way, which is by quadratic formula. And you'll be surprised to know that the quadratic formula is really completing the square underneath. Okay, so let's deal with that when we come to it. So that's going to be in your next lecture. I'm sorry, that's 9.3. Okay, that's section 9.3. There is really yet another way, which is graphing, and that's covered in 9.4, although we hardly ever use that to solve. Okay.